I'm going to introduce our next speaker. We're really happy to have here from Honeycomb, which is doing some really cutting-edge stuff in the world of observability, kind of defining the market, really. We're lucky to have Christine Yen.
Thank you. Hello. Welcome back from lunch. Thanks for coming to my session today. Today I'm going to talk about how, even though observability is a topic that people typically associate with over there in production, with, okay, it's like kind of like monitoring, but has some other stuff attached to it, I want to talk about how this is a mindset and set of tools that benefits developers almost more than it benefits operators. Can I get a quick show of hands? Who in the audience identifies kind of a little bit more as a developer than an operator? Cool. How about people who are like, no, I'm an operator through and through? And who's like, I really like bridging those worlds? Awesome. I know, it is definitely cheating. There's going to be a lot of like words that seem like they're cheating here. Awesome. I am also a co-founder at Honeycomb. We focus on empowering engineering teams to understand their systems in production. And when I say engineering teams, I mean both dev and ops and the bridge. And as a disclaimer, a lot of the screenshots, some of the screenshots I'll be showing will be from Honeycomb because we dog food, and those are all of my recent examples. But all the practices I'm talking about should be generally applicable to whichever tools you use. So who am I? I'm Christine, and I'm a developer who loves being in a room of ops folks. I really like the cultural changes that we're undergoing in this industry. I really like this idea that Peter in the DevSecOps talk really pushed on, where we're all on the same team. We should be working together. So we'll keep that in mind. These days, the software development process is already usually really customer-focused, right? And it's fairly well developed. We've got all of these stages in which we know how to be responsible and ship code that will be reliable and won't make the security folks angry at us. And we do all these things, and we ship, and we celebrate. Really, more often than not, after we've shipped it, we sort of just wait. We assume that everything will be fine. And we forget about it until an ops person or a security person comes knocking on our door and is really grumpy because something broke, because there was a bug, because there was a problem. And something like this might make us respond like this. And you end up with this divide where people are like, well, you didn't do your part, you didn't do your part. But what happened then to that diligence and that curiosity that we had in all of those steps pre-production, right? All of those rigorous requirements gathering and testing. Because in the end, this is what brings us together, right? This is the same name on the top left of that business card. In the end, we're all just trying to deliver a good experience for our customers, our end users. And so we should be thinking about things as much as possible from their point of view. From the developer's perspective, we can use data that's being generated by code running in production to really explore what our code is actually doing. And as a result, we can inform not just what we build, but how we build it, how to scope those things, how to make sure that the code that we write will continue working. And we can even use data in production to figure out how best to roll something out. Like the continuous delivery for databases talk, right? How to, what the potential impact will be, how to make sure my code is rolled out smoothly and works along the way. Because during the development process, we have all sorts of questions about the how and the why and how we're building things. And all of those questions might not smell like production monitoring, but should rely on kind of constantly looking at what's happening in production to answer them. Because not all interesting things, not all things that I care about as a developer are necessarily problems, right? They're just who's using it and how. Not all interesting things are going to show up on a dashboard. If you think of dashboards as things that you had to curate ahead of time, what I care about today might not be what I cared about 2 months ago when I set up that dashboard. A lot of those questions might not show up in my exception tracker. If this is the only tool that's available to your developers to understand how their code behaves, how can they? How can they do any sort of proactive exploration if everything's backwards looking? And so this leaves us to have to go seek out that knowledge. Because all of the interesting things about my code and how my code might behave are going to be these hypotheticals. And they're going to be things that are like, okay, well, what about this particular customer? Or what happens if a customer sends in that particular workload? What does normal mean for my use case? And we use this word, observability, which is sort of, we use this word because it captures this curiosity. It captures this mindset of, I want to ask new questions about what my system is doing. Textbook's answer for what observability means is understanding a system based on its external outputs. I like to think of it as, I expect it to behave this way, it being my code. Why is it instead behaving this way? Because monitoring is an important discipline and an important part of shipping software. But when you think about monitoring, it's like putting your software in a box and saying, okay, well, I expect it to do these things, and let me know if it does these things, and then I'll get angry at it, or get someone else to get angry at it. Whereas observability, again, we want to capture this curiosity. We accept that the system is going to change. We accept that often we are going to be the ones that change it. And we want to be able to ask these unknown questions, to find outliers that might not have been outliers or issues a month ago, about 6 months ago, a year ago. And so we're all here today, we're all trying to bridge these parts of our organization because there's now too much code in production for developers to not take ownership of what gets deployed. If the first wave of DevOps was about teaching folks to automate their processes and do infra as code and all of these good things, the second wave has to be teaching developers to own their code, teaching developers to steward their code, to continue borrowing words from this morning's talks, to steward their code as it goes live. And so observability should be a core part of what we think of when we developers are shipping software. As softwares are as it's being built also, not just when it's being evaluated for reliability or when we're trying to go through those security checkboxes. It's got to be something where we are constantly feeding useful information into each step of that process. Because as much as testing or documentation, understanding what our code does or is currently doing or what our old code is doing in production teaches us to build better software all the time. It's not just for finding out when things are broken or when things are going wrong. It's about understanding where that baseline is and what you expect that new work you're doing to do. So if we take a look at this big long list of all the things that developers do, we can break them down into a few kind of categories, right? Debug, figure out what we're building, or why, like figure out, is this person who's complaining about a legitimate problem? Figure out how to build a darn thing. We verify, make sure it works on my machine, write your tests. Verify again that it works after it's been shipped. And we watch. And when I look at this list, those first 3 items, build, debug, verify on my machine, what informs each of these by default? Is it just our fantastic developer intuition? Sorry? Tests? Yeah, but how do you know which test cases to write? Maybe we have a PM telling us, okay, these are the things you care about. But man, it'd be really nice to not have to rely on just my genius, as much as I want to rely on my genius. I want to be able to rely on what is actually happening. I want something more concrete that I can look at. So I'm going to run through, and we're going to blow through some real-world examples on what each of these stages might look like to kind of create that feedback loop so that I, as a software developer, know how to build better and better code. This talk is shortened for this time frame, so I'm going to blow through them. If anyone wants more details, find me afterwards. OK, debugging. So this is almost the most boring case for me because there's no shortage of people telling software developers what to fix and what to build and when to do that. But data comes into play when someone complains at you and you're like, is this really a problem? When you're debugging locally, you have all sorts of all the tools, everything in your ID right there that you can be as diligent as you want to figure out what's happening. But in production, we only have the data that was emitted at the time that it happened, right? And in a perfect world, we have all the data that we need, all of the entities, all of the little variables that we would have in our IDE, and we can replay the past. Since that's normally not the case, one of the things that we have to keep in mind is in our tooling, we should be making it as easy as possible to add new data as we need. So, quick example. Honeycomb, we ingest a bunch of data. We let you query over it really quickly. We usually hold ourselves to a very high standard of kind of like a second between the time it hits our API and when it's queryable. So when a customer comes to us and says, my data's not showing up, we usually panic. We don't panic. We jump on it. And one of the things that we added as we were trying to debug one of these complaints is something that we call, terrible name, event time delta sec, right? What is the difference in time that the user thought the event was captured and the time it actually hit our API? I'm going to jump into this and we'll see if this works. Okay, great. This is Honeycomb. These two graphs are essentially distribution of latency, distribution of that delta. So we can see, okay, well, how long did it really take, right? Because if a user is complaining to me about their data not showing up, all right, well, let's see. We can see that this, up here, there are a very small number of requests that have a very long delay. And we can actually say, okay, well, tell me what's special about this. Let me see if I can line this up with what the customer is complaining about. We can go down and actually see, yes, well, there's one team. This is very hard to do from far away. There's one team over here. All right, I can't mouse over it, but you can see the yellow bar. Yes, okay. This team lines up with the person who's complaining. Great. I can, in fact, confirm this user is experiencing something. Hey, did you know, by the way, that there's this long delay that we're seeing from your system? Maybe this is something for you to improve. And the reason I like this example is that it first lets you confirm a qualitative report with quantitative data. But second, it lets you be more informed about how to go about addressing it, right? You could sit otherwise on your hands for hours with your colleagues theorizing as to why a user might be seeing something. But by instead reaching for data, adding that data, and querying it back, we can actually make sure that our theory will address the problem. Okay, well, I mentioned building the darn thing. Understanding the potential impact of our change that we're making is like step one for, okay, what is the code we're going to write? And sometimes, our understanding of what is normal is not necessarily what's actually happening in production. Right? If I pointed at you and I was like, how fast are most of your requests being processed? Right? Like, okay, I don't know off the top of my head. But if I have a task to improve performance, or if I have a task to make end users feel like our product is faster, I better know what that baseline is so that I can measure. What I like about this mindset, what I like about this, and which is another thing, one of the reasons I feel like this observability mindset plays so well with dev, is that instrumentation, in a way, it's like these debug statements in production, right? It's, okay, well, I think I got here, and I think it should be like this. Let's actually measure, capture that data, and see in order to write better code and ship better experiences. I'm going to jump ahead. Okay, so I don't have a visual for this, but one of my favorite stories along these lines is someone who was building a service where they essentially came up across an NP complete problem, right? Okay, it's an optimal packing problem. They didn't want to actually waste a bunch of engineering time trying to come up with a perfect solution. So they basically picked 3 engineers. They were like, okay, each of you come up with a different implementation of this. We'll run it for a while. We will capture the outputs. We won't use them. We won't actually act on the outputs of your algorithms. But by capturing it, we can actually use that data to figure out which algorithm works the best for our use case, for our customers, for our workload today. And there's a delicious kind of data-driven mindset here that really allows engineers to not just write code in isolation to come up with a perfectly, theoretically perfect solution, but instead see how it behaves work quick and dirty, and be grounded. Okay, test cases. Testing is important, right? Whenever people say test in production, I see some people cringe, and it's like you always follow that up with also test before production. But coming up with test cases is a lot of, often involves a lot of intuition. I've seen it asked in like software interview questions, right? Like, what are the test cases you would come up with to make sure this works? Well, that's one way to do it. You can also use production data to figure out which test cases are worthwhile. Again, we saw this graph earlier. This is a distribution of the number of event columns per payload. Oh man, just by, if someone asked me to write some software that behaved differently depending on how large certain payloads were, I could pull those numbers out from underneath my chair, or I could look in production and see, okay, it looks like most of the payloads are in a certain band, but I should make sure to handle some outliers as well. And this cycle, this like, oh, I should write some test cases and immortalize certain behavior, and okay, well, I should go see what's actually happening in production, is why I sort of feel like pre-production testing is never going to be enough. CI and CD are a way to kind of capture and automate things that you know, but there's always going to be stuff happening in production that you don't know, that you won't anticipate. And I don't know when, 2 months from now, 2 years from now, the maximum payload size starts to go from 500 to 5,000. Okay, so when testing on your machine starts to creak, what do we do when we aren't quite sure? What do we do when we want to test something out on production data? And we want to kind of check its impact, or check the impact of our code in some lightweight way. So testing in production doesn't mean only testing in production. And it's important to think about, right? Like, okay, well, if I'm looking for a condition, or if I'm checking and I'm checking the behavior of something that I do know, where I'm like, okay, well, when I do X, it should spit out Y. Great, immortalize that in a test case, shove it into CI. When you don't, there are lots of things that then let you, that you should be taking that code and figuring out how to roll it out carefully to simulate that, to see what it is like when you do that actual versus expected assessment on production data. Because ultimately, there's some things you can only test in production at scale with real customer data on a real network. And the more we migrate to microservices and adopt Kubernetes and really embrace all these moving parts, all we're really doing is embracing a much longer list of ways that these things can interact. And we need to be able to adjust our processes to capture and to debug and kind of investigate and test all these different scenarios as well. Speaking of our favorite way to test a hypothesis, we love feature flags. Shout out to Lon Starkley. We're big fans because they let us test in production while making sure that the change that we're shipping is actually one that we're happy with. And what I love is, this is a list of our kind of old feature flags from the past. We can take any of our top-level metrics that we care about, right? Latency, or overall volume, or some other thing that we're measuring about the customer experience, and we can slice it by any of our feature flags. And so what we do now at this point is we basically take all feature flags that are active, and we capture the values that they return, and we send them along with essentially every request that hits our query engine. And that way we can pinpoint, hey, we're about to roll out this change to 10% of our customers. We don't think that this change should have a performance impact on them, but let's make sure. And there's something really delightful about using a tool that is intended to be lightweight and ephemeral and developer-friendly, like feature flags, and use that to make our observability tooling more friendly and ephemeral to developers. Because the more that people can get in the habit of running experiments or being flexible in how they think about production and deploying, if we take that and introduce it to how people think about working with production data, then you get this really great, you start to move toward this world where devs aren't like, oh, well, production, like, that's what happens after I merge to master, and that's someone else's problem. You start to make it something that people internalize on their own. And the last one I'm going to blow through quickly. This is the monitoring. This is the what happens after it's in production. But if the goal is to help developers make sure that reality lines up with expectations, let's make sure that even this step is done in terms that developers understand and are familiar with. I'm going to tell an example from my life pre-Honeycomb, in which I built an analytics product and constantly had the ops people coming over to me, tapping me on the shoulder, and showing me Cassandra throughput graphs. And they'd be like, Christine, Cassandra writes are through the roof. What are you doing? And I would just be like, I don't know. Like, I don't know how to map your database throughput writes to the actual code that I'm writing. But if the ops person came to me and said, hey, Christine, Cassandra write throughput is up for writes coming from this particular customer and this endpoint, boy, that immediately helps me understand how to map that to my code, where to go looking for this, how to repro this. And by having literacy, familiarity, comfort for both ops and dev in the same set of tools, just by including some of those nouns that devs deal with day to day, it's so immediately impactful for making someone feel comfortable doing something they wouldn't ordinarily be comfortable doing. And this example is a graph that basically shows the top is overall request volume, the bottom is latency, but each of the different colors is a different build. Because, I don't know about you, deploys aren't always instantaneous. Here we're actually seeing a couple builds running concurrently, which is a pain in the butt to figure out sometimes. But it really lets you pinpoint, okay, I see this change. What are the code changes necessary? Or what were the code changes that impacted and caused this change to happen? Because this is how we bridge that DevOps divide. This is how we help devs start thinking about what happens after we ship and helping them form hypotheses about what code will do in prod. Form a hypothesis, you add some instrumentation, or you use the instrumentation that's already there, you query the data to investigate that hypothesis, and you repeat. And this cycle just builds up kind of comfort, familiarity with, okay, I'm going to write this code, but let me actually think about how it's actually going to behave in the wild, so that people don't have to, so that we can, we can get that nice blue bar that Peter showed in his slides, so that we can just focus on building instead of causing that bug triage loop to continue occurring. So in my last probably 7 minutes, we're going to blow through a whole bunch of different ways to get there from here. I'll toss these slides online also. But the first 3 is going to be about instrumentation and how to start kind of getting in a good place. And then how we should be thinking about getting data back out. And finally, tracing as a beautifully developer-friendly approach to this whole space. So first, capturing really contextual structured data. And this means capturing metadata along the way as the code is being executed so that everything is in one place and ready for analysis. And in one place is really valuable rather than like having a counter over here and a counter over there with maybe some tags. Knowing that it actually took 72 milliseconds to serve the HTTP request and 25 milliseconds to render and 15 for the database on this one unit of work, then makes it trivial to actually tease out things that are real correlations rather than like, okay, well, these numbers changed at the same time. Were they actually related? Common set of nouns, consistent naming. This is sort of, again, the let's all talk about things in the same way rather than you calling it app_ID and you calling it application ID and someone in the corner doing like I don't know, something else. Instrumenting from the perspective of what we can control. As software developers, like, again, it's easy to think about, well, this is just my component and it runs on my computer, but instead of just that, hey, I know what I'm seeing. I know what the user is sending to me. I know a little bit about the environment that my application's running in, and I know what it's sending back, right? Even just that is often enough to help isolate what is the customer seeing, and is my software behaving the way I expect it to, right? These are the test cases, again. And even this database, this black box over here, I'm not going to fork MySQL just to instrument it. That's crazy. But I do know, again, what my app is sending to it, what my app is getting back. And once you start thinking about all these communication channels that are connected to the software that I'm writing, instrumenting in order to get a complete picture of what my software is doing and faced with isn't quite as scary anymore. So this is, you can think of that whole cycle previously as that unit of work. And lots of libraries out there that do kind of basic automatic instrumentation of basic HTTP things. But then you start with that baseline, you turn it into something that is valuable for your business, right? Metadata that is custom to your business logic. Because things like hostname, machine type, like awesome, that's a useful baseline for understanding where a problem is happening. But it's not as interesting for the software developer to figure out how to fix something as things like which build is it in, which feature flags were active when someone encountered that problem, or someone with the performance characteristics with a particular experiment turned on are. Again, infra stuff, these infra attributes aren't as useful as which customer did it impact. Maybe you have one huge customer and a lot of small customers. Understanding where that customer fell, where that traffic fell, is huge. And again, and just going kind of zooming in incrementally, that what is actually happening when this code executed? How long did things take? Which fork in the code did this request follow? Culture of experimentation, being willing to add temporary fields and then remove them, are necessary for being able to move fast. All right, instrumentation shouldn't be a thing that you set up once and then stays set, right? If it was, we'd be monitoring. Instead, instrumentation should be something that lives with your code. It's like comments, documentation. There are things that help you understand your code, and so if your code is changing, instrumentation should as well. Migrating. Okay, to ground, this is rough. We're going to ground these concepts in reality, what this might actually look like, to go from unstructured text logs, right? First, we take those entities that make sense to us, that are important to understanding the flow, and making sure they're in our logs. That's step one. Then we start introducing some structure. Then we start pulling them out, because logs are meant, printfs are meant for humans. And beyond a certain level, logs aren't human scale anymore, they're machine scale. So we need to start thinking about what it will look like for machines to pull information out, be able to find patterns. Introducing structure. And it's usually possible to do this in a non-destructive way. I say this because some people are like, well, but people really rely on that particular string that they search for. Okay. Think about and look at the types of things that people are going to be searching for, but don't let that stop your organization from being able to level up in your log hygiene and your data that you're generating. Building up context. So this is something where if you have, lots of people are like, well, what do we do when we have these interleaved log lines? And I want to do some analysis, and can you tell me when thing A happened before thing B? I usually come back and I'm like, well, yeah, if you're a data scientist, you can usually do intense MapReduce jobs. If you're a developer, you are even more empowered than that. You can structure this at the source. You can do something where you pull together these relevant bits and actually say, well, it's not just, I started it here and I ended it here. It's, I tried to do this work and it took this long and it failed in this way. Boy, isn't that a lot easier to reason about after the fact than trying to find these two log lines that happen near each other? Because logs are for humans and for preserving history, not for analysis. And we need to be moving toward in a world where we are thinking about analysis, figuring out when something happened. I'm going to tracing. Tracing is really just groups of logs structured in a particular way that makes it easy to reason about. And man, I'm running out of time. We're going to zoom past that. Tracing will be commonplace. It's the most native way for developers to understand and see in production kind of how their code is executing. This is our mission. I'm going to throw this up there and get off stage before someone pulls me off. But very interested. My DMs are open. Grab me. Hopefully, if there's an observability or observability-related open space today, I will be in it, as will my colleague Danielle probably. So thank you so much for being a great audience. I will be around all week, the next couple days. Come find me.